Alright guys, here we are with 8.2, adding and subtracting rational expressions. Remember, rational just means that you're stacked up on top as a fraction. Okay, so if we're adding and subtracting fractions, we need to have a common denominator. Alright, we need a common denominator. Alright, and an LCM, or a least common multiple, is another way of kind of saying or expressing common denominator. Alright, so imagine that these are the denominators of three fractions. Okay, you got 1 over 16x, 1 over 8x squared y to the third, and 1 over 5x to the third y. And we need to find the common denominator, or the least common multiple. Alright? This isn't technically that tough of a thing to do. You did a version of this, a much easier version of this, probably without any letters, in like, I don't know, junior high math, pre-algebra, stuff like that. Okay? So what we're going to do is we're going to break this down into its prime factorization, and that's going to kind of help us decide what's going into the least common multiple. So 16 is 4 times 4 times x. Actually, we could break that down even further, couldn't we? 2 times 2 times 2 times 2. Prime factorization there, Mr. Handke. So we got 2's. So this is going to be 2, we had 4 2s, so 2 to the 4th times x. Okay. 8 is 2 times 2 times 2. And then we have our x. You don't need to really break apart the letters. You can just leave them there with their powers, x to the third and y to the third. So we have 2 to the third, x squared, y to the third. And then we have 5. There's really nothing to do there with 5. X to the third, y. Okay, and now what we do is you're going to go down the line and pick the biggest power of each factor. The biggest power of each factor. So I have 2. Okay, 2 to the 4th, 2 to the 3rd. This one does not have a 2. So the biggest power of 2 that I have is 2 to the 4th. Alright, x's. X squared, x to the third. The biggest power of x I have is x to the third. Oh, I missed my 5. We'll slide that out in front. 5 to the first. Okay. And then y's, y to the third and y to the first. The biggest one is y to the third. Okay, so we have 5 to the first, 2 to the fourth, x to the third, y to the third. Alright, and we could multiply the 2 to the fourth times 5. Alright, 80. So our least common multiple, or what the common denominator would end up being, is 80 x to the third, y to the third. That would be the common denominator that we need to get for all three of those to add them together. Okay, so that particular problem, I think for kids it somehow ends up being more difficult than actually applying it down here on the actual problems, for whatever reason. Okay, so if you have a better way or a different way of thinking about that, you are more than welcome to use that. Okay, that's just the way the book kind of presents it, and that's the way that I've kind of learned it before, so that's what I'm going with here. Alright, what about when we have these polynomials that we've been working with? Okay, yesterday we were multiplying and dividing. We don't need to have a common denominator for that. We can just multiply and cancel out. But today when we're adding and subtracting, in order to add and subtract, we have to have that common denominator, so we need to figure out what they would need to be. Okay, so if I factor this out, I can take a 3 out and a y out of each one. 3y, y minus 3. Okay, and think about what this bottom one's going to be. Multiplies to 15, adds to negative 8. How about y minus 5, y minus 3? Alright, so they both, and this is kind of something I guess that we didn't hit over here because we didn't have it pop up. So we said you take the biggest one. Well, what if it's a y minus 3 to the first and y minus 3 to the first? If it's there twice, you only take one of them. Alright, over here we always took the biggest one. Okay, if it's a tie as to which one's bigger, you only write it down once. So we've got 3y, y minus 3, okay, tied, so it doesn't matter, pick one, and then y minus 5. Alright, and we're just going to leave it like that. Okay, so the least common multiple, or the common denominator, would have been that. Okay, like I said, those, like how that's presented, somehow ends up being more difficult for students. Okay, when we're actually using it, like in these next ones here, they do a little bit better. Okay, so there's nothing in common. These are both prime, and there's nothing in common. All right, 5x, 4y to the third. Okay, nothing really to do with this one. So in order to get a common denominator, this one's pretty easy. When there's nothing in common, you're going to have to multiply this side by 5x, and this side by 4y to the third. Okay, what that's going to give us is we'll have 48y to the fourth plus 25x squared all over 20xy to the third. Alright, and that's it. Okay? So see, we're taking that and we're doing kind of this up here with it, but when it's kind of written like this, it's a little easier just to do it. Okay? 12 and 18. Okay? 12 and 18. So we could either do like this break it apart stuff up there, or you can kind of think, what's the first number that 12 and 18 would both go into? Okay? 18 times 2 is 36. 18 times 3 is 54. 18 times 4, 64, 72. Okay? So we had 18, 36, 54, 72. What about 12? 12, 24, 36. So they would both go into 36. Okay, they both go into 36. If you wanted to do it the other way, 12 is 2 times 2 times 3. 18 is 2 times 3 times 3. So you have 2 squared times 3 and 2 times 3 squared. So if you take the biggest one, you're going to get a 2 squared and a 3 squared. 4 times 9 is going to give me 36. So that's the same way to think about it. Or, okay, what number do both 12 and 18 first go into? 36. So I need it to be 36. Okay, they both have an x, so 36x, that's not a problem. Y to the third. Alright, so I'm looking to get 36x y to the third for the common denominator on the bottom. So now think about what each one needs. What does each one need? This one's going to need a times 3. It has the x, and it's going to need the y to the third. So 3y to the third, 3y to the third. This one just needs a 2 times 2 to get to 36. So times 2 times 2. Alright. Okay, now, so 3 times 7, we're going to have 21. Y to the fourth minus 2 all over that common denominator of 36xy to the third. Okay, 3 times 7, 21. Y to the third times y. Y to the fourth. 1 times 2. Okay. Put them together over 1 denominator. Bingo. Alright, so that's with chunks or monomials. What if we have polynomials? Okay. It's actually kind of going in reverse. Alright, so to the book, this is like example 1, example 2, example 3. So you would think easy, medium, hard. And to me, I think, or at least my experience with students in the past, it's about the opposite. Like, this one ends up being the easiest one. Okay, so what we need to do, we need to factor. Alright, bottom left, this is going to factor out to x plus 3, x plus 6, and this one's x plus 6. Alright, so they already have the x plus 6 in common. This one over here is going to need an x plus 3, and then they would be the common, they'd have the same denominator. So x plus 3, x plus 3. Okay. So, didn't need to do anything over here, so that's already just going to be 4x. Alright. 5x plus 15 over x plus 3, x plus 6. Alright, and that's going to be 9x. Put those together. See, this is our first time having to combine things at the end. 4 plus 5x is 9x plus 15. And we can leave our denominators factored, but the tops we should clean up a little bit. But the bottoms we can leave like that. Okay. So there we have it. 9x plus 15 over x plus 3 times x plus 6. Alright, I'm looking at 9 and 15. I'm seeing they're both divisible by 3. Sometimes the book gets a little tricky like that. They'll give you something where after you combine it, now you could factor out. So if I take a 3 out, let's just double check this. 3x plus 5. Okay. No, it wouldn't cancel. But sometimes the book will give you some crazy problem. Or at the end, you could maybe factor something out now after you combine these. You could factor something out and cancel on the bottom, like you did in lesson 1. So sometimes the book can be, whatever you want to call it, tricky, mean, whatever, you know. You got to watch out for those at the end. They don't happen very often, but they do happen occasionally. Alright, I'm going to give you, let's have you hit pause and try to do that same process here with this one. Alright, let's take a look, guys. So check your denominators. Multiplying to positive 27, adding a negative 12. So we have a y minus 3 and a y minus 9 over here on the right. On the left, we have a y minus 3. So this is going to need a y minus 9. So I go y minus 9, top and bottom. We'll have 8y minus 72 plus 2y minus 5. And this can get tricky if this is a minus. So we'll look at one of those here in a minute. Over y minus 3, y minus 9. y minus 77 and there we have it, 10y minus 77 over y minus 3, y minus 9. Okay, let's see what other types of problems we can get. Okay, we got some special challenge problems on here on the back. Okay, let's take a look. We got 3a plus 2 over a squared minus 16 and a 7 over 6a plus 24. So both of these are going to be able to be worked with here a little bit. So So this is a difference of squares. Perfect square minus perfect square. We have a minus 4, a plus 4. And then this one's both divisible by 6. So I have 6 out in front. A plus 4. Okay, so this time both things are going to need 1. And we have a minus situation, so that makes it a little more tricky as well. Alright, so this has an a minus 4 and a plus 4. So it's going to need, it doesn't have the 6 yet, so it's going to need a 6. 6, 6. Okay, this one has the 6, it has the a plus 4, it does not have the a minus 4. Okay, so a minus 4, top and bottom of that one. So now we have that common denominator of 6, a minus 4, a plus 4. Alright, got a little work to do, got to distribute. So 6 times 3a and 6 times 2, we got 18a plus 12. And now here's the tricky one, the minus. People always miss this. This is going to be a minus. Well, I can't do a minus half for this stuff because it's all multiple choice, so you got to be careful here. Minus 7, that is going to be a negative sign on the 7. So we'll have minus 7a. Negative times negative is going to be plus 28. Alright, now we'll put these together. 18 and a minus 7 is going to be 11a. 12 and 28 is going to be a plus 40. All over 6. A minus 4. A plus 4. Alright. And again, okay, 11 and 40. No common numbers there. Otherwise, sometimes the book is tricky like that, where you might be able to factor out the top and cancel something off the bottom. Okay, let's see if you can take that and apply it to this next one. There's 3 pieces. Okay, it's the same idea as 2 pieces, but there's 3 pieces. They all 3 have to have the same thing. Go ahead and hit pause on that and let's see what happens. Alright guys, let's take a look. And usually when there's a 3-piece, it's pretty nice. Okay, they're not going to be too mean to you. Alright, what do I mean by pretty nice? This is usually going to be made up of this and this. Maybe there's going to be a times 2 in the front of it, I don't know. But usually it's pretty nice. Right, like this did end up being x minus 1 and x minus 8. And hey look, x minus 1, x minus 8. So this one needs the x minus 8. This one needs the x minus 1. And this one already had the x minus 1 and x minus 8. Okay, so our common denominator is x minus 1, x minus 8. Alright, we already know what that is from the first one. It wouldn't have killed you to rewrite that like that, multiply it out, but we've been leaving it factored all day today, so it's fine. Okay, the first one we had was x squared plus y. Okay, nothing tricky with this one. 4x minus 32. Alright, this one is the minus, and kids always miss that, minus 3. So this is minus 3x, minus times minus, a plus 3. Okay, well, what can we combine? Okay, what can we combine? Alright, we got the x squared out there. Plus 4x minus 3x, let's go with the plus 1x. Minus 32 plus 3, we'll go with the minus 29, and then we'll throw that plus y down at the very end. Alright. So, when there's a multi-piece one, usually the book is pretty nice. Sometimes it might need a 2 or a 3, just a common multiplier throughout there. Okay. Perimeter of a rectangle. Perimeter of a rectangle. Remember, perimeter of a rectangle is around. So, you're like, oh man, we just did a 3-piece. This is going to be a 4-piece. This plus this. Okay, remember rectangle, the opposite sides are the same. So this would be another one of those. And this would be another one of those. And add up all 4? Yucky. Okay, yeah, you could do that. It wouldn't be that bad, considering the 2 denominators are going to be repeated. Alright, or think smarter, not harder. Remember rectangles, if these 2 are the same, I should be able to do this plus this and double it at the end, and that would be that. Alright, so let's just do these 2 and then double it at the end. Okay? Don't confuse this with area where you're going to be multiplying them together. This is perimeter, we're going to be adding these 2 together. So we would have 3 over x minus 2 plus 4 over x plus 1. Okay, there's nothing in common here. This is going to need an x plus 1. This one's going to need the x minus 2. Okay, not that bad. So we're all over x minus 2, x plus 1. 3x plus 3, 4x minus 8. Okay, 7x minus 5 over that. Alright, now don't forget what the plan was. The plan was to add these 2 and then double it at the end, because we have those again, those same 2 again. So don't forget to now double it. Okay, when you double a fraction, you only multiply the top by 2. So that's going to be 14x minus 10. Alright, and there it is. Inches, yards, feet, whatever they tell you in there. Classic problem, though. They love to tie in geometry back into this algebra whenever they can. Alright, last problem we're going to look at today. It's a combo problem. A little bit of today's tied with a little bit of yesterday's. Okay? So, we need to get a common denominator on the top. I could easily rewrite 1 as x over x. And so that way on the top, we have x plus 1. If I change this 1 to an x over x, so the common denominator is x plus 1 over x. And a y over y. Okay, because this denominator is a y, so 1 would be y over y, common denominator here. So now this is y minus x over y. Okay, think back to yesterday. What did we do? What did we do when we had fraction over fraction? Multiply by the reciprocal. So we're going to multiply by, now y is flips on top, over y minus x. Okay, and just to kind of keep with how we've been doing things, right, we leave the bottom. We've been leaving the bottom, well, I should put that bar here. Leave the bottom factored, x times y minus x, and we've been simplifying the top, xy plus y. Alright, I'll rewrite that. xy plus y over x times y minus x. Okay, it's okay. We've been leaving the bottoms factored, and then we simplify the tops. Alright, so you might have some of those, some crazy things like that. Fractions over fractions. We're just going to tie in today's with last class's. Okay, we're going to have to do the common denominator, combine the top, common denominator, combine the bottom, and then now comes lesson 1, fraction over fraction, flip it up and multiply. Sometimes it works out where nothing really changes. Sometimes it does work out where things would cancel even after that, kind of like yesterday's or 8 ones. So be on the lookout for that. All right. Thanks, guys. Good luck. Let me know if you have any questions.